Okay, now let's start to look at what's really powerful in structured text, especially as opposed to everything else. This is where it starts to look a little bit more like computer programming. So let's go ahead and put our emulator back into program mode and go offline. And then I'm just going to get rid of everything that we've got. And the first thing I want to show you is a conditional statement. And that's also called an if-then. So what this is basically, think of it like whenever you're programming ladders, you have conditions on the left and actions on the right. In essence, what you're saying is, if the things on the left are true, then do the things on the right. Well, we have that same ability in here, and we don't have to use XICs and XIOs, although I think you might end up agreeing at the end that they might even be a little bit easier, but that's okay. I still want to show you how to do this. So let's make a simple block that says, if we're in run mode, let's go ahead and run our pump. Or if we're in fill mode, let's go ahead and run our pump. So how would we do that? Let's start by typing if, and then we're going to have a bool which is going to tell us that we're in run mode, or we might have an int that's going to control our mode. In this case, let's say that we have an int, and that int is called mode. So if mode equals, and our fill mode would typically be mode 2, because we would say that 0 is off, 1 is standby, and then we would say maybe that 2 or 3 is going to be fill and the other one would be drain. But let's say that 2 is fill in this case. So if mode equals 2, then, and then we're going to come down to the next line, but first of all, let me go ahead and create a new int for mode. So if mode equals 2, then pump colon equals 1 semicolon. So now we're saying that if that's the case, then go ahead and enable the pump or run the pump. And we're going to set that up as a new bool. Hit create. But what if we're not in mode 2? Do we still want the pump to run? Well, we don't. So then we'll say else, which means otherwise, and that's going to be pump colon equals 0 semicolon. And I think that's going to be the end of our if statement. So then we'll just type end underscore if semicolon. So let's try this out. Let's go ahead and emulate this and see if it works. So I'll go up here, download, and tell it to go ahead and make that happen. It looks like I have no errors, which is always a good thing. So let's go ahead and put this thing into run mode, and right away you can see that we are in mode 0, therefore our pump is not running. If I put us into mode 1, our pump still does not run. If I put us into mode 2, look at that, our pump came on. And if I put us into mode 3, our pump goes back off. So that's how it looks. We've got a simple if statement here, and we could very easily compound that if we wanted to. So let's go ahead and put this back into program mode and go back offline. And what else would we want? Well, maybe between fill mode and drain mode, we would want our pump and our valve to work opposite one another. So we want to check to see if we're in fill mode. We also want to check to see if we're in drain mode. And we want to evaluate both of those conditions. So what does this look like? Right now we're in mode 2, and we're looking at the pump running. Well, if the pump's running, we're going to say we want the valve to be offline, or we want that to be de-energized closed. So we'll say valve colon equals 0, and then we will define our valve, and that's going to be a bool. And then let's try something else. Here, let's say we're going to add one more condition, and that's going to be ELSIF, else if. So otherwise, let's check something else. And this else if is going to be, what if mode is equal to 3? Then what do we want to do? And in that case, let's say that we want the exact opposite of what we've got in fill mode. If mode equals 3, we're in drain mode. So we want the pump to be off, and we want the valve to be open. And then we have an else. So what does this mean? If we're in mode 2, then do this. Otherwise, check and see if we're in mode 3. And if we are, then do this. And then if none of those are true, then let's just come down here and do whatever's here. And we're going to set the valve and the pump both off, de-energized. So let's give this a whirl and let's see if this works. We're going to go ahead and download that. There we go. Got it? Okay, so let's go ahead and put ourselves into run mode. And there we go, we're green. And we already know what we're looking at down here. So let's just jump right in and try to set the mode equal to 1. And everything's still off. Let's set the mode equal to 2. Now our pump is on, but our valve is closed. Let's put ourselves into mode 3. Now our valve is open, but our pump is off. And then when we go back up into mode 4, well, everything is off again. So that's how one of these conditional statements works, and it works like a charm. So perfect. That's one of the powerful things that we can do inside of structured text. That's not all. I also want to introduce you to the concept of loops, and there are several different kinds of loops available in structured text. For now, I really just want this to be an intro to loops, so I'm going to start you off with a for loop, and that one is what will just kind of take us out of 5000 technology. So let's take ourselves back offline, and we can get rid of all of the hard work that we've already put into this now. So what is a loop? Sometimes when we're running a program, we want something to happen over and over and over again a certain amount of times. And we want to be able to control how many times that happens. And there are ways in ladder logic to make that happen, but I don't think it's quite as intuitive as it is in here. That being said, it can be done a little bit faster and simpler in ladder logic, which again is why I'm such a fan, but I do want to show you how cool this is in structured text. So let's check this out. So maybe the easiest way to explain this is just to start typing it out and explaining it as we go. So for, and we need to give ourselves some kind of tag that's going to count for us. So let's go ahead and call that maybe count. For count, colon equals 0. Where do we want our count to begin in this loop? And 0 seems like a good place to start counting. So for count equals 0, how high do we want it to go? To 100. And that means that we're going to do something over and over again while count starts at 0, and then we're going to keep going until count equals 100. And for all that, we want to do something. So, okay, what do we want to do? Well, the first thing I want to do is I want to give ourselves a count tag. So there we go. And what do we want to do? Well, maybe I want to take another tag and I want to add 2 to that tag every time. So we will come in here and create a test tag, and I will assign that equal to, and that'll be equal to test tag plus 2. And then we'll end with a semicolon, and I will create my new test tag. So I'm going to take test tag, which will start off as being 0, and then I'm going to add 2 to that every time. And so now I have my for, and I'm telling it what to do and from what range. And now I'm going to go ahead and type end underscore for and semicolon that. And if we run this right now, here's what's going to happen. It's going to count from 0 to 100, but the problem is it's going to keep going over and over and over again, and we don't want that to happen. So we need to do something to make sure that that doesn't keep repeating itself over and over and over again. So let's put one more thing in here, and let's fall back on our if. We're going to say if count is less than 100, or actually we'll say if count is less than 1, then, and that's when we'll go ahead and do all of this stuff here. So just to keep it simple, I'm going to tab out, and I'm going to create some good indentation so we can actually see what's all buried inside of what. And then down here I will end my if. So when we first start off, our count is going to be equal to 0, and then this is going to run it up to 100 and end the 4, and it should only run one time. So let's test that theory. Let's go ahead and download our program. Alright, and we can see our count and our test tag are both equal to 0. So let's go ahead and run this up, and as soon as we do, we ran through our loop one time and then we stopped. So our count went up to 101 because it also included the 0 value, so actually we had 101. If we wanted 100 iterations, we would have had to go from 0 to 99. Like I said, my math isn't the best, and we ended up at 202, but hey, that's still within 1%, so I didn't do too bad. Anyway, that's how a for loop works, and there are do-while loops. And as far as conditions go, we don't just have if statements, we also have case statements. And I will maybe get into those in a later section, or maybe you can look into those on your own. They add to it, but do they add enough to really go, deep into them and give a bunch of examples of all of these? No, not really. Just with the if and the for loop, you can already see what kind of stuff can be done. Now, setting up ladder logic to do the same thing, you can do it, but check that out. That's pretty simple and small and elegant. And if you're used to structured text, you can throw this kind of statement out really fast. So, there really is some benefit to structured text. But I think something that you're going to see with all of these paradigms is that the main benefit of them is being able to use them together. When you put them all together, you can capitalize on the strengths of each while mitigating on the weaknesses, and you can actually create a program a lot faster when you know how to play all of these things together. It's going to be harder for other people to read. It's not going to be maybe as reusable in the future, but when time counts and you're the only one that's using the code and it's kind of a one-of system, you can definitely get a lot done fast using multiple paradigms, even structured text. So that's it. We're going to come back in the next lecture and we are going to try to put together a program, not for our entire tank fill system, but at least for a part of it. We're going to try to actually make something work in structured text. So I'll see you in the next.